So thank you again for joining today, and I will be talking about using the Smart Factory to accelerate commercial space exploration. And I think in order to really understand what that means, first I need to explain who is Elite Aerospace Group. So let me show you the agenda for today. I'll just start by giving that intro, who is the Elite Aerospace Group, and then more specifically, who is Elite Aviation Products, because that's actually who is going to be using what we're talking about today. One moment, I just need to put someone on mute. All right. I think that's better. Now, I will also introduce the concept of IIoT. I think probably people are familiar with the idea of Internet and possibly have heard the phrase IoT. And I'll explain what is IoT, what is IIoT, and then, of course, what did it look like as we implemented that at EAP. Probably the most important thing is what are the lessons learned, and then, of course, what comes next. So we'll be discussing all of that and then should have a chance for some questions at the end. So, intro, who is Elite Aerospace Group? For today's discussion, we're going to be talking about essentially the first two branches of Elite that you see listed on the tree. So Elite Aerospace Group is our parent company, and Elite Aviation Products is the segment of the company that's focused on manufacturing, and that's primarily in metallic pieces. I'll get into some of those products in just a moment. And then the next part of the company is Elite Engineering Services, and that's the group that's focused on doing design work, design for manufacturing, CNC programming, and my team, which focuses on CAD, PLM, and IoT, as well as some augmented reality. So in this case, the Engineering Services group is actually setting up the Smart Connected Factory for aviation products. So it's a little bit confusing because there's several groups that are referred to as Elite, but in my case, it's the Elite Engineering Services group doing work as for Elite Aviation Products, who is essentially the customer of Elite Engineering, and then EAP'S got their customers, which are buying the metallic parts and the manufactured assemblies and such. So I'll try to keep those separate. EAP is the manufacturing group, EES is the consulting group. So the manufacturing group has several different facilities. As a whole, Elite Aerospace Group is approximately 200 employees. And the focus is mostly on the aerospace and defense sector and new space. New space meaning suborbital launch and orbital launch, particularly the companies that are kind of just getting started. So, for example, SpaceX is one of our larger customers. So we do a lot of work for them, as well as some of the older companies that are in that space as well. For example, Raytheon doing satellites and, well, components for their satellites. So as far as the machines that we're going to be connecting, we've got quite an assembly of them. You can see just kind of generically, we've got 3, 4, and 5-axis CNCs, as well as Swiss turns, turn mills, and even a wire EDM. Actually, I didn't even list it, but we also have 3D printers as well. So we do have some capacity for additive manufacturing, but that's mostly for prototyping. So EAP's focus really is mostly metalworks, and the additive manufacturing is still plastics. We don't have any metal additive manufacturing yet. Wouldn't be surprised if that's coming in the near future, but not yet available to us. So some of the products that we're talking about, there's a big scale of both complexity and volume. And typically, the more complex something is, the lower the volume, and the simpler it is, the higher the volume. So you can see pictured here kind of the scope that we're talking about. On the left, the picture that you're seeing, those are inserts, various aerospace standards. These in particular are the NAS 1830 series, 1831, 1832, 1833, etc. And these are fairly low complexity and very high volume. So as far as EAP is concerned, these, of course, have very different requirements for the factory of the future or smart connected operations than something like what you see on the right. Now, obviously, Elite didn't build the entire Falcon Heavy, we just did some of the components. So some of the brackets that you can see in that picture there. I, of course, just love to share this picture because you can see things that came out of our factory with the Earth in the background. So it certainly makes it look more complex. But in this case, typically that means a lot lower volume. There aren't rockets going up every single day. There's only a couple being launched every year. So even if there are lots of the brackets on each rocket, it's still relatively low volume. So these parts have very different requirements than the standards that we might be producing one every couple seconds versus some of the satellite parts, it might be producing one every several months. When you're monitoring the machines, that, of course, creates different requirements and different information that you want to get off of those. If a machine is down for 2 minutes, that might result in loss of product for, if you're talking about one every second, that could be 120 inserts that haven't been produced because the machine was down for 2 minutes. But when you're looking at a part that's going to take months to actually produce, 2 minutes of downtime doesn't have the same impact on the business. So when you're looking at monitoring and using Thingworx to keep an eye on your equipment, those requirements do have a pretty significant impact. So what are some of those concerns that EAP has? Well, unplanned downtime. When is a machine down that you weren't expecting it to be? You need to know about that because if a machine is down, you don't necessarily have one operator for every machine. So if a machine is down, it's possible it could be down without you knowing for a prolonged period of time. The longer a machine is down, the longer you're not making any money off of it. So it really comes down to how profitable is your business. By monitoring all of our machines, we can improve our overall operational performance. But using the data of when are we producing parts, we can also be able to plan maintenance. By planning the maintenance, that really has two effects for us. We can decrease the likelihood of a machine going down for unplanned reasons, preventative maintenance. We're going to do something to the machine when we schedule it rather than having something go wrong and impacting our schedule. But we can also plan it into our schedule. We can plan the maintenance when we want to as opposed to having to fix it after it's already been broken. Of course, doing that maintenance also helps with the quality by changing tool bits as necessary, making sure that it's operating nominally. We're going to get the best quality parts. And, of course, that's what EAP's customers particularly care about. But EAP also mostly really looks at what is the real-time status. How do we know what's currently happening? Because like I said, we don't have one person for every machine. So we need some way to know what's the current state. And we also need to know when are things being completed. This can also give us an awareness into the schedule. So by knowing what the real time is and monitoring it, we can keep our schedule up to date. We'll know as early as possible if we're going to miss a delivery date for any reason. If everything is operating perfectly, we know we're going to meet our deadlines, great. But if a machine is down, maybe it's down for 3 hours, we can see how is that going to impact our schedule, and we'll know as soon as possible. But then lastly, like I've kind of already implied, if we have one person watching 5 machines, would it be possible using something like Thingworx to have one person monitor 10 machines? This is pretty direct cost savings because less people working the same number of machines means that it's costing us less to operate them. We can improve our margins. That would help make our business significantly more profitable. So what are some of the tools that we're talking about? Here's just a couple of images so you can see what they look like. There's a big variety of them. So there's several types of lathes. There's several types of mills. These come from different manufacturers. Sometimes it's the same manufacturer but a different brand. And then even more confusing than that, sometimes it's the same manufacturer, the same brand, and yet different controller. So the software that's on the machine might be different even if the hardware is the same. And all of that has to be considered when you're planning your IoT dashboard. How am I going to monitor all these machines that on the surface might look the same, but on the back end are different, or frankly are going to look very different as well because it's a different manufacturer, perhaps a different type of machine. So what do the customers of EAP care about? Well, they want high quality, which means everything is accepted. They don't want to have to reject anything. They want to be able to know that it's right the first time. They want as low cost as possible, and of course they want it as quickly as possible. They want to be able to place the order and get it as soon as they say they want it. So not necessarily produced the fastest, but produced when they want it, more of a on-time delivery than early delivery. But they also care about visibility. They want to know, what is our factory status? Are we operating as we said we're going to? If they could use a dashboard and look at how our operations are going, they could better plan their schedule as well. Perhaps by looking at this and saying, oh, we see that Elite has capacity, they might send us some additional work. And that's an option that we've discussed. We haven't explored at length because giving visibility into our current factory status could bring up some other concerns. For example, if we've got two customers that are competitors, we don't necessarily want one competitor to see that the other one is having parts manufactured in our plant. If they are trying to schedule something, maybe they know that we're close to schedule or maybe even running late, and yet they look in the dashboard and they see we're producing something for a competitor of ours that could cause problems. So as of right now, we haven't implemented that, but customers have discussed it with us. So it's certainly something that our customers are interested in and could be a way that we add value to our customers using IoT. So again, something we're discussing, we haven't yet done. So here's some of those machines that I was referring to. This is our factory floor. You can see some of the lathes pictured out. As you can see, they're kind of lined up. They all look very similar. These are all the same manufacturer. I believe there's actually two different models pictured here. But you can see, again, there are a couple of machines that are operating without someone right next to them. In this case, this picture, you can see a few people that are checking on things, probably doing a quality inspection, perhaps a first article inspection. But the machines are somewhat of a set it and forget it sort of mentality, which means monitoring becomes really important because we aren't currently doing just that. We don't have someone standing there watching the machine. We need to know what's going on. So what are EAP's concerns? Well, they, of course, everything that their customer puts on them, but they want that real-time reporting. How do they know what's currently happening? Because without something like a dashboard, you need to have someone walking around the floor looking at each machine and seeing what it's doing. But most importantly, how do you improve your overall operational efficiency? Efficiency is code word for cost. How do we reduce our costs? That means less time spent monitoring and less downtime. And that downtime is key. But then the other element is equipment forecasting. Well, right now, we may or may not know the status of our machines, but we also may or may not know the capacity. If we win another bid, do we have the capacity to take on that work, or do we need to buy another machine? And the machines are not cheap. They can range. They could be $100,000. They could be $1 million. So using a dashboard, we can collect the data. We can see how well a machine is being utilized, and we can determine if we need to spend the money. And the savings from something like Thingworx could actually come from the money not spent, as opposed to saving us in time or capacity. It could be we didn't spend $500,000 on a machine that we might have otherwise bought. So just knowing what are we able to do with what we currently have. And that's what I mean by equipment forecasting. So to kind of summarize what set Elite on the path of using Thingworx, these were the objectives. We were concerned with quality, free capacity, but then also kind of going forward, the paperless factory. How do we get to a point of not passing paper around? Paper has some inherent problems. The moment you hit print, it's out of date, or you may not know if it's out of date, and you'll never know, because even if you put a timestamp on it, you can see that this was printed this morning. I still don't know if anything has changed since then. So going paperless is definitely a goal of the future, and this is one of the steps that we need to take to get there. But then shop floor optimization and information access kind of tie into that as well. How do we get the access to the right people all the time? Anyone that needs access should have access to it, but as an aerospace and defense sector, you have to care about security. We want to make sure that only the right people get the data that they need to. And using Thingworx can help us with that as well. So in short, reduce cost, ensure quality, and then increase customer response time. But you can see I've kind of laid out some longer-term goals as well. So now let me give you a little bit of an intro into IIoT. So first, let me talk a little bit about the Internet. And this is what everyone's familiar with when you say Internet. I'm going to call it the Internet of People. It's just a network. It's a connection of people, and people are sharing information, and that's all it is this network of information all being shared around somehow. And it can come from any source. It could be an email that you sent out. It could be a tweet. It could be something that you read on a website. It could be Facebook. It could be pictures. In the end, it's all ones and zeros, but it represents data coming from people. It's how we network with each other. So it could be LinkedIn or Facebook, a social network, but again, it could be information. It could be news stories or pictures. So that's the Internet of People. We'll take it to the next step, the Internet of Things. And this is probably the more common phrase that you've heard, IoT. It's one of the newer buzzwords. Well, the Internet of Things is the exact same thing as the Internet of People, except replace the source. You still have a network, and its still sole purpose is to pass information around. The difference is, where's the data coming from? Instead of coming from people writing tweets and people putting up posts on different networks, it could come from devices. In this case, we're looking mostly at commercially available devices. It could be a smart thermometer, a thermostat in your house. It could be an Amazon Alexa. It could be a camera. It's the same mentality. We're sharing information. It's just between devices. And this is what's going to really take off. It's, well, been already happening, but it's a way that these devices share information and become more efficient. It could be the smart meter at your house telling you what your electricity usage is. When an alert goes off, it could trigger from one device to another. This device monitors something which tells this device to go do something else, which is really the same idea as a tweet. One person sees this restaurant which has great food, so they post a picture of it, which tells some other people to go to that restaurant. Well, in this case, it could be this device notices that there's a spike in electricity, which tells this device to change its behavior. It's the exact same concept. Like I said, replace people with things. So to take it one further step, IIoT is the exact same thing as that, except now it's industrial Internet of Things. And instead of a commercial device, something that you might buy on Amazon or at Walmart, we're talking a little bit heavier industry type tools, type machines. It could be robots. It could be things that you would see in a factory, like a CNC, a mill, a lathe. It could be a 3D printer. And it can also be a database. And in our case, you might be looking at an ERP system. For example, I've listed Epicor. But it could also be a PLM system, like Windchill. It could come from the cloud. It could come from a physical device. But again, it's the exact same thing. Internet just means a network of things or people sharing information. IIoT is the exact same thing in the industrial world. So I've mentioned a few times, what is Thingworx? Well, I'm going to go ahead and break one of my cardinal rules of never just reading a slide to you, but I think it's important. What you see here is the definition of Thingworx, and this comes right off of PTC's website. You can see I've cited the location if you want to go read a little more. Thingworx platform is a complete end-to-end technology platform designed for the industrial Internet of Things, the IoT. It delivers tools and technologies that empower businesses to rapidly develop and deploy powerful applications and augmented reality experiences. So that's what PTC is officially saying Thingworx is. I tried to simplify it a little bit. Let me give you my definition of Thingworx. It's the industrial dashboard. And the reason that's helpful is we talked about a network, and it's all of these different things passing information. But without being able to get that data and organize it, it kind of looks like the picture on the left. Every device has to talk to every other device. It's not very efficient. It's not easy to see everything, because now if you want to find out all this information, you've got to go to all these different places. So to kind of bring it back to the Internet of People example, this would be you going to Facebook and you going to Instagram and you going to your email and going to your news source and collecting all of that information, each one individually. You've kind of got to connect each one, pull it, see what's useful. On the right, this is what Thingworx is hoping to achieve, and it's that single dashboard. From one site, I see everything. So Thingworx connects to all of the different sources, and in one location shows you everything that you need to know. It's nice and it's displayed in a graphically pleasing way. You can see the information. You can go back and forth and look at what's most useful. You can record the data to see the past. You can look at real time, and everything is organized in a nice, clean fashion. So the left is kind of just a network on its own, and the right, we've added in our industrial dashboard to see everything in one site. It's the single pane of glass to get everything that we need to. So this is roughly what the hardware looks like. From the client side, you are looking at, in this case I've used a computer, but it doesn't have to be. It can be a tablet or a smartphone as well. That connects to a domain name server, which you can see then is connected to Thingworx. And you've got essentially two pieces to this. One of them is kind of real-time versus the database, storing the previous data. And then we're using KEP server, which is actually then allowing us to connect to the different machines. So those machines are your CNCs, your lathes, your mills, your 3D printers. This is the hardware. This is how the actual network is set up. What's it look like on a software side? The client is going to look at a web browser, and that's really the interface that they see. So the picture of the Thingworx dashboard that you saw previously, they're seeing it in a browser, and it can be effectively any browser, anything that supports HTML. And that's connected to Thingworx, and then you can see kind of referencing the real-time versus historic. You're connecting to either a SQL database or to KEP server directly and pulling information from the machines real-time. So this is kind of how it all connects, how you get everything that you need to. So to kind of map it out, what does the digital manufacturing journey look like? Well, these are kind of the 3 steps that we're taking to get there. And at the moment, this presentation is kind of focusing mostly on just understand. I've talked a lot about monitoring. Well, that means what's happening real time. So you can see unified connectivity. That just means connecting everything, all the different machines in the factory. And then real-time identification, knowing what's happening right now, just monitoring, seeing if there's a problem right now. Going into the future, we want to look at how do we advance beyond that. We want to start to predict. And predictive analytics is kind of the key that we were planning to focus on, which means how do I predict in advance when something might fail? This way, we can do things like preventative maintenance. So based on the data that we've collected in the past, we can see when this behavior came up, it caused this to happen. So the next time that something like that happens, and it could be we've noticed an increased number of vibrations on the machine. Typically, that leads to bad parts. We're going to stop the machine, and we're going to take care of the problem before bad parts get produced. So we're going to really significantly help our schedule by eliminating any of the bad parts that have to get remanufactured. We're saving money because we're not producing bad parts that have to get either fixed or scrapped. And we can better plan the utilization of our machines by doing planned maintenance instead of unplanned downtime. You can see there's a lot more to the map, but there's only so much time to talk about, so I won't get into too much more of it. I'll talk a little bit about augmented reality using all sorts of devices. You could use something like a HoloLens or RealWear, or even a tablet or smartphone to see something in augmented reality. And that could be as simple as a work instruction, getting the experience to show you what's the next step in the manufacturing process. And that AR experience can be controlled in a PLM system so that you know it's always real time, it's up to date. And then you can do the same thing for your quality inspection. But you can actually use augmented reality for maintaining the machines themselves. So when you have to do that maintenance, someone that is only a little bit familiar with the machine might still be able to do all of the more advanced work rather than having to call in a more experienced technician that might be less available or more expensive to use. You can use these devices and get the support you need. One of the newer technologies that PTC's been showing off, the Euphoria Chalk. Try to imagine combining FaceTime and augmented reality. You can, as a person in the factory, pull out your phone, make a call, walk around, and talk to an expert. And they can draw on their screen and show you, and it'll stay in space. Oh, this is the button I press. This is what I have to do. And they'll walk you through the process. So now you can get the help that you need to fix the machine or do the maintenance faster and without having to rely on the expert being physically present. So just a taste of some of the things, and this is still just in the advanced stage. So certainly when we get to outperform, there's even more that we can do and more we can leverage. So what's that implementation look like? So at EAP, we have multiple locations. They're spread out around California, mostly around Orange County. We focused on a single facility. So we're just going to look at this one factory. We're going to connect to the machines in this one factory, and then we'll scale it up from there. So this is our layout of the factory that we're talking about. Here's the plan that we took. So first, we're going to do a proof of concept, just make sure that this does what we think it needs to do. And we started off simple, and we just use a microcontroller, or if you're more familiar with it, a Raspberry Pi. With these, you can actually do a lot of different things for what it is. It's a pretty impressive microcontroller. But we've really just used it for a couple simple measurements just to prove that you can connect. You can collect the data. So the next step, once we've kind of moved past that proof of concept with the microcontrollers, we then had to actually start acquiring the software. So as you saw in the software map, we had to get Thingworx and configure KEP server, since KEP server is what's actually connecting to the machines. So we've set up KEP server, we've configured it, we connect to the machines, and then, and this is probably the key point that we took in our path, we decided to just use the out-of-the-box manufacturing apps without any customization. Some configuration, of course, but nothing custom. So we're not putting too much time into this. We wanted to just get started as quickly as possible to be able to start collecting data as early on as we could. The next phase later on, and we're kind of just starting to touch on it now, was actually app development. Now, once we've collected data, we want to design our own apps that will get us even further value to it. So the out-of-the-box manufacturing apps are really designed for that quick start mentality. We just want to connect machines and start going as quickly as we possibly can. And so you can see from that initial, hey, let's test if this is something we could do, to the actually collecting data, that was happened in just several months. And that was actually with a lot of delays along the way. I'll talk a little bit more about some of those delays when we get to the lessons learned, but as you might expect with any implementation, there's always a certain slowdown of, well, we need to buy a server, we need to get management's approval to spend the money. That takes longer than it should. So there's a lot of idle time built into this. If you actually have pre-staged all of the equipment and the software purchases that you need, the whole implementation could be all done very, very quickly. And that's the entire idea of the out-of-the-box manufacturing apps, is to allow you to do that. You can connect and start getting data and start getting useful information from that data, or at the least the real-time monitoring in probably only a couple of days. So at this point, we've now got the manufacturing apps, and I'll get into what each of those are. We'll start with the app development. Well, let me show you what it looks like. So this is the dashboard, and you can see there's one app here that has our logo. That's our one custom dashboard, but everything else is just out of the box. That's what you get from PTC. We haven't had to develop these at all. So we've laid it out. You can see it's kind of designed to be expanded on. So this is one location. So our Irvine facility, and this view is as high level as it gets. It's really designed for someone like a CEO. They just want to know what's the status at each factory. They don't necessarily want to see every individual machine. They don't necessarily want to see the history of all of them, but just in total, how are all of the factories doing? Well, in this case, there's only one factory connected, but you could see the next one could just be a click away. But from this one view, here's where it's physically located. You could see when there's others, they would be shown on the map, and then a rough status for each of them. Running, under maintenance, they're planned to be down, or unplanned. So from a CEO's perspective, this is a pretty good status. You can see our Irvine location. There's one machine in unplanned downtime for whatever reason that may be. Maintenance means they're currently doing something. Maybe they're putting in more coolant, putting in more material, fixing something, changing a tool bit. Planned downtime is, well, it's not operating, but we expected it to be. Could be for something like doing inspections. First article inspection might be ongoing. And so when the machine stopped, the operator would just indicate that this is an FAI inspection, and then it shows as a planned downtime as opposed to unplanned. Later on, when we look at the history, we'll be able to see how long was each machine down and for what reason. Again, our goal is to reduce the unplanned downtime. So this one view shows you some of that. As you look at a little bit more detailed, here's the one factory, and you can see all of the different machines laid out, color-coded to show their status. And as you click on any one of them, you can see the machine, what it looks like, what it's currently doing. So in the top left corner, you can see that machine is selected. That one is showing as running. You can see what manufacturer, what model, what controller. So in this case, it's a Tsugami with a Fanuc controller. You can see what's it currently producing, what's the status. As you click through, you could see for all the other machines, different types. Well, in this case, all of the ones lined up on the left are the same type of machine, and then off to the right are the CNCs and the mills. So again, another layout. In this case, there's a status shown to the right of the lathes, kind of to the left or middle of the other machines, where it's just a simple stop sign configuration. Green means good, yellow means okay, red means bad. Well, in this case, yellow is showing planned downtime. It's not currently operating, but we know why. Red meaning unplanned. The machine is stopped, but we don't know why. And it could just be a simple stoppage, or maybe just no one's using the machine. It may actually be a planned downtime. We're not using the machine because we don't have a part to produce, but if someone hasn't indicated that it's planned as opposed to unplanned, it'll default to unplanned. And you also might see a blue dot floating out in space. That represents the microcontroller, that Raspberry Pi device. It's not actually physically located in the plant, but we just put it on the map as well. So you can see we're not limited to the stop sign configuration. We can choose different colors to indicate all sorts of things. As far as a factory operation goes, traffic light configuration certainly makes sense, though. So what are those manufacturing apps? Like I said, out of the box, they're designed to be quick and easy setup, give you what you need for real-time data. So the three ones that we're talking about are Controls Advisor, Production Advisor, and Asset Advisor. They kind of show the same information because they're all pulling the same data. It's just presenting it differently. The way I like to think of it is who is the customer kind of shows you what each one is geared for. So one is kind of geared more for a manager that wants to see an overview of all of them. Production Advisor might be for someone like a general manager of the whole factory. They don't necessarily care about a product line or a type of machine. They want to know overall how's everything doing. And if they see a problem in a certain area, they're going to contact this other person to go deal with it. Versus an Asset Advisor is more about each individual machine. I want to see this machine, what is it currently doing, what is the past performance, digging into the data a little bit deeper. So each of these, again, same sort of information, just laid out a little bit differently, presented to meet a different customer's requirements. So you can see the description on each of these slides of what each one is. This is just the description as written by PTC. I've copied from their website, so I won't read it to you. But I put these slides together so you can just see roughly what each one looks like. So in this screenshot, you can see for the Irvine facility, you can see the devices and the status, what the timestamp is, and what's currently going on. You can configure it to show a sort of different things. Do I want to show their status, the number of devices, the types of devices, et cetera? So controls, kind of putting everything down, really is just looking at unplanned downtime. How do I increase productivity using this app? Production Advisor, you can see now it's laid out a little bit differently in the end, really still coming from that same information though. In this one, it's more about availability. How often is something available? A little bit more focus on performance as well. So you can see the key metric here, overall equipment effectiveness is what's being monitored. Is something available? Were there any problems? Is it down? And you can record that and put together that information based on the past performance. And then Asset Advisor, it's more of a listing of every machine. For each one, you can kind of go through and see for each individual platform, what is it currently doing and what has it done in the past. So you can see in this image, again, the top, that's the microcontroller. And then for each machine, you can really configure it however you want. You can put in the model information, the serial number for each individual machine if you want. You can give each one different names. So for example, at EAP, a lot of machines are actually named after investors that helped bring that machine online. So you can keep track of your machines by the serial number, the location of them, or a colorful name like the investor names that you'll see labeled on the different machines. So this is very configurable. Again, out of the box. This wasn't a tool that we had to create or really customize. It was pretty simple to set up, configure it, and get it starting to work the way that we need. So where are we as far as that? Well, you can see the 3 different out-of-the-box manufacturing apps are all focused on that understand state, just real-time monitoring. So using those, we can see what the current status is. We can compare to the past. So that's entirely where we focused. We have plans going forward for the next phases for advance and eventually outperform. But again, just set up what's delivered from PTC really gets you that first level pretty well. You don't have to do much in the way of customization. It's not a huge effort to set up. So did we achieve our goals? Well, the key was monitoring and setting up alerts. We want to make sure that we decrease the downtime. And at EAP, that really happened just because once we had a dashboard, people were able to see what the status was. And we noticed that as soon as people were able to look at what's going on, actions were taken. Machines were no longer down for as long because people were able to see that they were down. In the past, maybe a floor manager might walk around the floor once every couple of hours. They might be at their desk doing other things. Somewhere around lunchtime, they walk around and they say, oh, wait, why isn't this machine operating? Well, now it's an HTML page. They can open up the dashboard at any given time, immediately see the status, and take action, whether that means by calling someone and saying, go deal with this, or going out to the floor to see what the problem is. So visibility was really the key reason or key benefit that EAP got from this. Of course, recording the information means that you can set up your metrics. Well, what do we intend to achieve? Did we achieve that or not? Setting up goals often drives people. Being able to say, did we meet our goal? Did we exceed our goal? Did we do better than last month? Are we continually improving? So that helps as well. And then did we achieve OEE? Just optimizing machines. Well, I kind of implied this earlier, but in my mind, maybe the key benefit is not spending money on something that you might have otherwise. So certainly by looking at the dashboard, we can see we have free capacity. So we don't need to buy a new machine. And in the case of these machines, that could be hundreds of thousands of dollars. So setting up a dashboard is relatively inexpensive compared to the cost of buying a machine that you actually didn't need. And that investment can be used on something to much more effectively improve your company. So the lessons learned in the implementation, well, as I mentioned, we had a significant delay just in the purchasing process. And this is not necessarily specific to IoT or any project, just something that needs to be planned for. You need to make sure that you have all of your assets lined up, whether that's software or hardware. There's a procurement phase that needs to be accordingly planned for. It's more specific to IoT. Connecting the machines was somewhat of an issue, and that means both physically connecting as well as adding into the dashboard. In order to actually use the machines, obviously they've got to be connected to the network, and that might mean running lines, actually dragging the LAN cords through the factory, making sure that there's a drop at every single one, make sure that they're all plugged in, but then also getting IT to actually add them and assigning each one of them an IP address. One of the issues that we discovered was that connecting the same type of machine doesn't necessarily always give you the same results. So getting the IP address off the machine was actually a little bit more complicated than we might have initially imagined. Once they are actually connected to the network, they've been assigned an IP address, of course, each one needs to be connected to Kepware. For each one of these, it's a little bit different process, and the controllers behind them are a little bit different. So like I said, sometimes you might have a Tsugami with a Fanuc controller, but maybe next time it might be Mitsubishi instead, and that's going to be different. The key that we found is each one of these has their own API, and it's not necessarily as simple as just reading the information right off the machine. It's not as clear as that. So you may need to do something like MT Connect to actually connect to the machine and really determine what is the code. Because once you're getting the data off the machine, it might not necessarily make sense to you because it is just a code. The manufacturers aren't necessarily giving that information away because it is a proprietary language that they've developed. So something like MT Connect will help you with that, so that now you're not just showing status of up or down, but you want to get much more detail than that. What is the machine currently producing? What's the part number that it's running? And eventually you should be able to read everything on this machine because the machine is being controlled by a computer that you should be able to connect to and read all of that information. What we found is it's not necessarily plug and play as we had hoped. The variety of machines was not necessarily a lesson learned so much as a challenge. You know, as I've said a couple of times, you've got different brands, you've got different controllers, you've got different types, but you also have legacy to contend with. So some of the more modern stuff, if you buy any machines that were manufactured in the past couple of years, they should be pretty simple, practically plug and play. But certainly a lot of these machines predate the concept of IoT. Machine tools are typically designed to last for decades. When you're spending $1 million on a machine, it better not have to be replaced every 5 years. So most factories are going to have machines that they bought from the 70s or the 80s that you want to connect. And that's going to be a little bit different challenge than a more modern machine. Another challenge that we faced, again, not necessarily something you could have better planned for, but relocating. And that means sometimes within the same factory or perhaps to another factory. So Elite has multiple factories and is starting to move machines around from one factory to another, relocating the assets to change the different business scope, whether it's going to be this type of machine or that one, kind of focusing one factory on a particular customer or particular product line. Well, that changes your dashboard to a certain extent. So you want to plan for that accordingly. Certainly your factory layout is going to change, but once the machine's been connected, where it's located shouldn't actually impact the dashboard that much. You might need to change it, on one page to another in the dashboard, but it's been connected, you're collecting the data, it has unique IP address, it shouldn't matter too much as far as the data that you've collected in the past, reconnecting it once it's been moved and getting back online. So you want to think about that. And I think I have this as one of my lessons learned. You want to plan for the knowns, but you always have to consider the unknowns. Businesses are typically not very static. Things do change. So when you build your dashboard, what might possibly need to change along with it? Is your factory going to move? Are you going to acquire a new factory? So we started with a single location with the plan of adding in additional ones. Well, if we had set this up as if we were a single factory and then later on opened up a second factory, it probably would have been very different. So fortunately, we kind of planned for additional factories. So as more factories come on, it's just one more page in that first view that I showed you, that CEO type view. So you want to consider those sorts of things. The other one that we really learned, unfortunately, the hard way is you want to make sure that your customer is involved. We tried to set up Thingworx and give a finished product to the customer and say, here you go, don't you love it? And by not really asking them what they needed up front, we showed them the first dashboard. It wasn't necessarily interesting to those people. The end user, that operator of the machine, they didn't see a value in it. And if they don't see a value in it, they're not going to use it. And so I'll show you in kind of the next steps where we're headed with that. We had to redesign the dashboard a little bit more because what, as a consultant, we might have thought initially was going to be helpful, turned out that same information is still helpful, but the way that it was presented is a serious concern that we needed to take into account. So had we talked with the end users earlier, figured out what their requirements are, we probably would have gotten to the end goal a little bit faster, a little bit more smoothly. Another one, you want to consider how much data are you collecting and how are you going to store it. Initially, we had to change to a larger SQL database in order to account for all of the data that we were collecting. Also, probably would have gotten to our end result a little bit faster if we had involved someone a little bit more familiar with the actual machine tools themselves, rather than engineers that are working more on the consulting side and the design side and the PLM side. Having a couple of people actually operating the machine involved could have pointed us in the right direction. So next step, like I told you, kind of the custom app development. So you can see in this case, we've laid out the machines based on the type. So instead of the whole factory layout, seeing all the machines in one location, we found the way the factory was running is one person is overseeing each type, the lathes in one view and then the mill type in another. So by just putting all of the lathes together in this view, they get the information they need without having to sort through the rest. And then you can see the top part of the page is actually where the operator can input the information that they need to. The specific job number, the number of parts that they're going to produce, when they expect it to be completed, when it needs to be shipped by, put in description as well. And now things like the machine state is going to be recorded off the machine, and you're coupling that with the information that the operator has provided. So you can look at, for example, the produced column and the required column. We can see how many of these parts do we need to make. Well, in this case, the lathes are typically putting out the very low complexity, very high volume items. So one person might be monitoring all 10 machines, and they'll lay out and say, okay, this first machine is going to be producing 4,200 of these inserts. The next one is 3,800. Maybe you can see it's a different part number. So each machine's producing a different part number, a different number of them, and now from somewhere else in the factory or possibly another location because it's all on the internet, I can see what the status is. How many of the ones that I need to produce have been produced? So as one machine is approaching, you can see Tsugami 7 is at 3,290 out of 4,000. I can see it's getting towards the end of its production run. Maybe now it's time to tell someone, okay, go over there and get ready to set up the next job. So one person can see all the items they need to in one location with the criteria that they're looking for. How far is it in its run? And in this case, like I told you, this is the high volume aspect. It's a set it, forget it, walk away. Real-time monitoring is key. And you can set up alerts. So maybe if you get to 3,300 and the machine stops or runs out of material, an alert goes out to tell you, go take care of something. Now in the future, those alerts can be tied to any data source. That means you could get an alert if the temperature in the factory gets too high, or there's too much vibration on the machine, or you're running low on coolant, or a door to a secure area gets opened. All of these are different data sources, so they could easily all get put together. So what comes next for us? Well, let's come back to that same roadmap so you can see that next stage of advance. Well, that means for us mostly the custom apps, the ERP PLM connection, pulling in the next data source. So right now we're not really pulling any information from PLM or ERP. But if you're at a machine and you're producing a part number, it would be good to, from one source, be able to pull that information. I might pull the job number from ERP. I might look up the engineering data from PLM so that as I'm producing this part from this one terminal, I can see the machine state, I can see the job it's being run, I can see the engineering criteria. If I need to inspect it, I can use that for quality as well. And then taking a little bit bolder step, and in my mind this maybe is somewhere between advance and outperform, you can talk about augmented reality, using that to move yourself in the direction of the paperless factory. There's a lot that can go into that. I think that's probably a topic for another day. So on our roadmap for what comes next, you can see just adding in additional machines. Like I said, we started with just the one factory and we have several, so adding in the other locations. And then connecting the databases, since again, those are just additional sources for data. And then custom app development, and longer term out, we'll be talking about augmented reality. And to give you kind of a quick taste of the custom apps, you can see, again, this is the same information. It's everything that you might have seen in that last view of the different machines, but we talked to the operator, we found out what they're more comfortable with, and even though stylistically this might look like something out of maybe the 70s or 80s, this is what the machine operators are more familiar with. So it shows the machine name, the type, and the number of parts that have been made. It also happens to show the location of the tool or the spindle. Not necessarily something we're recording in the history, but real time, that might be something that they want to see. And so this looks a lot like the display that you might see on a mill. It's what they're comfortable with, so that's what we present to them. A similar type of presentation makes it a lot more useful. And of course, again, I keep mentioning it, but getting into augmented reality, you can see here a quick mock-up, so a physical mock-up, as well as taking the models that were used to design that mock-up and displaying it in augmented reality. So you can see side-by-side comparison. You can do both physical and virtual mock-ups. Later on, you could actually blow that up. You could put on something like a HoloLens and walk through it. So if this is obviously scaled down because this is actually a cabin that someone would be in, the sleeping quarters for an airplane. You could walk through it and see what it looks like, get the better feel for it, and do your design review that way. Rather than having to do prototyping, you're going to use augmented reality. You could use that to help in your manufacturing and quality processes because now you can look at the parts. And again, this is all controlled in PLM, so you know you're up to date. You don't have any revision control issues, and you can add instructions into augmented reality as well so that you can give someone a smart device, HoloLens, whatever, and follow the step-by-step. What do I do next? What do I do next? What do I do next? And then validate what's been produced. Later on, we can talk about using it for service aspect as well, showing someone out in the field how to repair something rather than sending it back to the factory, which would take longer and cost more. So I think that covers a fair amount of material on how we're using the Smart Connected Factory. At this point, I'd be happy to take any questions if anyone has any. While I wait to see if there are any questions, just a quick pitch. This is a bi-weekly webinar that we do. So the next one will be 2 weeks from today, and that one's going to be focused on what's new in Windchill 11 and 11.1. So it'll kind of assume that you already know what's available and what the features are in Windchill, and just be showing what's new since then. So new features, updates, and talk about what's useful in updating to those. All right, well, I don't see any questions coming in. I do encourage you, if you have any, please let me know. And, oh, I am getting a question. Does Thingworx allow control of devices? The answer is yes. So certainly we're using it just for monitoring, but you can use Thingworx to control a device. And actually, a great example that PTC showed at LiveWorx, they were using Thingworx to control, they built a model airplane, so it's got servos controlling the flaps and the ailerons and the rudder. And from Thingworx, essentially they're just moving the mouse, from Thingworx, they're moving the mouse around, and it adjusts each of those control devices so that it would fly the plane towards that device. So just moving the mouse around the screen is essentially like flying a joystick that you would use to control an RC plane. All of that's being done through Thingworx and through the cloud as well. So they had the laptop and the plane sitting just a couple of feet away from each other, but it could be done a couple hundred miles away from each other as well. If anyone's interested in seeing that demo, I can help find a video of it for you. So please let me know. All right, well, thank you everyone for attending. Please let me know if you do think of any other questions. You can see my contact information listed here. Don't be shy about sending me an email. And I hope to see some of you again in 2 weeks when we're talking about wind chill. Well, thank you very much, and have a nice day.